Can you guys do question 1, please? You will need these following formulas we talked. These are the formulas for the testing hypothesis for one sample. We learned this in the week before the Easter break. You may remember, or you may not remember if you had too long of a break. Use these formulas to do question 1, all the questions on the sheet. Just do question 1 using these formulas. Question 1, please. Question 1 on the sheet in front of you. Yes. Okay. Eddie, I've got a job for you. Let me give out this table. only give it to the people, not everybody, not every place. Yes.
You know what? You work out 7 in the tables. I've worked out 7 in the tables and got 1.96. And then is that from the, you know, the transfer test? That's 1.72 for the right region or
That should be graded, so you will accept.
So
That should be graded according to this, you see.
yeah.
This you reject if this is greater than this.
Oh, okay.
You reject if this is greater than this. Otherwise you accept. You guys done question 1, guys? It's easy peasy, Joy. These are the formulas you need to use to do all the questions on this sheet. Sheet number 11. Right, which rule will you use? Shh. Guys, among these rules, which one would you use to do the testing? Huh? Which ones would you use? Huh? Come on guys, talk to me. So you reject H0 if root of n, which is 400 divided by sigma, okay? Are you with me or not?
Is it
Do
40
you see? Huh?
Is it 40 or 400 then? I think it's 40.
So 40 or 400? 40, yeah, sorry. Sure. Thank you, I'm blind, you see. 40, yeah. Okay. Now there are two values for alpha. If alpha is 0.05, then this becomes now you got all of you got the table in front of you, right? Can you read this please? What is Z 0.975 equal to? 1.96. And if alpha is 0.01, Can somebody read this for me, please? 995 in the table. Can you find it in the table, guys? Hmm? 995 99. So 2.5 2.575, yeah, 2.575. Do you see how we got this? Shh. No? Why is that? Why no? Somebody said no? Look, you should read it. You should look at this table, right? This is right, and you have these two. So this is 2.57. This is 2.58. So it's halfway in between these two. So it's 2.575. That's what we got. All right. So this is question 1. Can you do question 2, please? The other parts are similar. So can you move to question 2, please? Now? Move on to question 2, please. I'll put the formula back on in case you need them.
For exam, would we need to memorize the formula?
Only the first column.
Okay. And like, I had this past exam paper.
Yeah,
Where it's- yeah, yeah. And because you said something about if it's half right, you get 50%, and if it's entirely right, you have 100%.
Yeah.
What does half right mean? For example.
Well, it's subjective. I mean, it's basically, I don't know, it's difficult to say. It's like half the number of steps, I guess. Half the number of correct steps. Looking for the answer. Yeah.
And it will be like previous years.
No, the start will be different. I don't think the start will be different. I think I'm measurements. Yes.
Right.
So when looking at past years, it's no.
It is a few, but if you get my email about the final exam, just go through the introduction of the kind of and the pieces. That is enough.
If it's greater than
From the format of incorporated
take into account the not
You guys do question 2, please. Now, question 2.
so because it's not equal to, we don't know if it's greater than, so we have to put odd signs. If it's so you use a Z1 and it's alpha, which is positive. If it's less than, you use a negative, but it's less going to be negative.
Yeah.
And part 2 it's just the same. So question 2 is integrating
Guys, you done question 2?
So this one, this one, so we're going to use
You all signed the apprenticeship, guys?
no.
Where's the apprenticeship?
Yeah.
Anyone else who hasn't signed?
It's saying you have to reject each part if this condition holds. So you know in this case is this
You okay?
if that holds, then you reject each part of it holds and accept one. Here we are. And then you
Alright guys, shh. Can you listen? What's the rule for rejection in this case? Huh? It's root of n, which is root of 10, sigma, which is root of 3, x bar, which is 0.7, mu 0, which is 0, greater than z1 minus alpha, which is 0.95. And this is 1.645. I assume you know how to read the tables right in front of you. This guy is 1.645. So this is the same as saying that root of 10 divided by 3 multiplied by 0.7 is greater than 1.645. Okay? Are you guys with me? So if you have a calculator, you can do this and see if it is greater or not. Of course, I'm not going to do it. I don't have a calculator. Right? Now part 2. Part 2 is to find the probability of type 2 error if mu is 1. Do you guys remember the type 2 error? It's the probability of accepting okay, and this is right. Now I'm gonna do something. I mean, I did this kind of questions in the lectures. You will remember this. Do you see why I'm doing this? Because the true population mean is 1, not 0. So I'm taking away 1 and adding a 1, right? Okay. All right. Now, what can you say about this guy? I think I talked about this in the lectures or some time ago. What can you say about this number here? Hmm? Standard normal. Yeah. Why? Do you remember why it is? I can remind you again. If you had forgotten, I will tell you one more time. If you have right, if you have a random sample from a normal distribution, it implies that x bar, the sample mean, has a normal distribution with parameters this and this, right? Or in other words, root of n divided by sigma times x bar minus mu has a standard normal distribution. Okay, so that's what I'm going to use. I'm going to use this property to argue that this guy here has a standard normal distribution. So it follows that the probability of n or 1 is less than or equal to 1.645 times this, right? And this is simply phi, the CDF of the standard normal, at 1.645. Okay, so that's the answer to part 2. Part 3, please ignore part 3 for the moment. Can you move to question 3, please? If you did not follow this, you can ask me now. Alright. You guys okay? Alright. Okay, are you guys okay with this, or do you follow this or not? Yes, you're right. No? Are you right, sir? Okay, good. Alright, can you guys do question 3, please, now? Question 3. I put the formula sheet back on. Question 3 is different. You're right. Where's the apprenticeship, guys? Hello? Somebody, yes, we got it here. Yeah, try it. You see, there are three columns here. The first one is where variance is known. The second one is variance is unknown. Third one is for proportion. Now, which of these two ones? How do you know the variance? How does it say you know the variance? Yeah, but this is the variance in samples. See, you have a sample of 250 columns. What you have here is the sample variance. Guys, have you done question 3? Given you enough time, guys. So which formula will you use? Will you use column 1 or column 2 or column 3? For question 3? 2, yeah. Good. Question 3, you're testing for your n is 250, your x bar, the sample mean, is 1. Your sample variance is 2484, and your alpha is 5%. Right? So you reject H0 if root of n, which is root of 250, divided by s x bar, which is n minus 1. N minus 1 is 249, comma 1 minus alpha by 2 is 0.975. Right, now we need to read this from the table, right? This is where your tables comes in. So if you go to the T table, here we are. This is 0.975. So you go down this column like this, and you look for 249. There's no 249, but the value closest to 249 is this one here. You follow me? Right, 100 is the closest number to 249. So what you have is approximately 1.984. So this is 1.984 approximately. Yeah. And if you have a calculator, you can work this out. You can work this out and see if it is greater or less than this. And if it is greater, then you reject the null hypothesis. Otherwise, you accept it. Yeah. All right, guys. Can you now move to question? The next one is, let me see. Can you do question 6, please, now? Question 6.
Yeah, I was about
Maybe I know a bit more. Maybe interested. This is a last call.
It's important to just the one about two about anyway, two about price,
Yeah.
about first one, just about that means you should go to half more. Or if you do a step mess up again. Can you do the quiz? Is it an NLE?
No.
Can you do question 6, please, guys? Yes, the formula sheet.
I know it says it. Peter the tree. So it sounds cool. Yeah, it's yeah. So X bar to position.
Alright guys, let's see how we can do question 6. I'm gonna do all 4 parts at once, okay? So forget about the different parts. So you will reject the null hypothesis if, so what's the rule here? Tell me, what's the rule, guys? Huh? N, which is times x bar, which is must be greater than z. Alright, so this is the rule for rejecting the null hypothesis. So once again, if you have a calculator, you can work this out and see if it is greater than 1.645. If so, you will reject, otherwise you accept. Okay? And the final step, what is the... Okay, so that's part... So this basically answers part 1 to part 3. Okay? Part 1 to part 3. Now part 4 is to find the probability that you will reject H0 when the true value for P is 0.55. So basically you need to find the probability that given that the true value for P is 0.55. Okay? Now you know how to do this question. I mean, I've done this a few slides ago. I did a similar question. So what you need to do is to change the 0.5 here to 0.55 and then use the normal approximation, right? Okay, so this is the same as sorry, the square root here missing. So I'm going to change the 0.5 to 0.55 because that's the true value of P now, right? Okay, and then because I have done this, I need to add something on the right hand side, right? So it's going to be 1.645 minus I have added 0.05, so 0.05 multiplied by this expression here. Okay, given that P is equal to 0.55. Okay, now you will use the argument that this guy here has a standard normal distribution. This guy here, because this is the true value for P. This must have a standard normal. So in the next step, we are nearly getting there. In the next step, you will say that this is equal to the probability that NO1 is greater than 1.645 minus okay. Okay, so that's the answer. If you have a calculator, once again you can simplify this. You can simplify this and write like that. Okay. So that's question number 6, guys. So I'll see you guys next week, and if you have questions before that, come and see me, And if you have done question number 10, can you please give it to me now? Thank you.
I'm confused. I don't know how have you answered the first 3 bits, because there's no normal approximation in here.
There is. Basically, this rejection rule is based on the normal approximation.
Oh, the rejection rule is based on it?
Yeah.
Oh, so you just, whenever you do it with proportion, you're always using the normal approximation?
Yes.
Okay.
Yeah. I mean, although I did not tell this in the class, but the rejection rule is actually an approximation based on normality.
Okay.
Okay. Yeah.
Okay, thank you.
Okay. Yes. All right. Thank you.
About this, when we found x dash for 78 over 920, is this from the binomial? How do we know this?
Because it's basically a binomial, but it's because it's n is the binomial of 478 is the sum of the people who have whatever the characteristic is. Yeah. So if you have a Bernoulli, it's a sum of a Bernoulli basically.
Okay.
So sum of a Bernoulli gives you 478, and you divide that by n.
And that's x
X
dash.
bar.
X bar.
Yeah.
Okay.
Yeah.
Thank you.
Yeah. Sorry. Yeah.
How can we judge whether this variable is
Because it says in this question it says sigma squared is 3, so it's not. But in this question it doesn't say anything about sigma squared. It only says that you have a sample giving a mean of this and a sample variance of this. It doesn't say anything about population variance. I mean, it doesn't say. And also in this question here, it says. It doesn't talk about a sample, but it says that a population has a mean of this and a standard deviation of this. Sorry, you have a question, yeah. So in this case, the variance is known, because it doesn't talk about a sample. It says that the mean of this and the standard deviation of this. All right, so this is the case where the population variance is known. And the same thing here. But here it's not the case, because here you're talking about a sample with the mean of this and the variance of this. So the sample mean and sample variance.
so the question 4 is
It's known, yeah. It's known. Yeah. All right, thank you.
I just wanted to say for the exam, which of these
This
forms
one.
do you need to memorise? Do you need to
This
memorise
one,
those
yes.
ones? Okay.
It's in the formula sheet on the course website.
Okay.
It says you will need to memorize this.
Okay,
Yeah.
and also for the questions, so it's the sample mean and the population variance that you need to answer the questions.
Yeah, population variance none.
Yeah, and
And-
sample mean.
Yeah, yeah.
Okay.
Yeah.
Also, can I borrow a pen to put my ID on?
Oh, okay, okay.
Thank
sure,
you.
Sure. You guys have questions?
Oh, no.
No.
Thank you.
All right, thank you. Yeah, thank you. Hi, you have questions?
Yes, next Monday it's a bank holiday. Will we have tutorials on Monday?
No, there will be no class on Monday. The university will be closed.
Oh,
So
okay.
there will be no classes. But on Thursday we will have tutorials. You
Okay.
can come to those.
Okay.
Yeah.